Hi, sunshines. So we are going to talk about proving that lines are parallel in a coordinate plane. So there are a few theorems that you need to know. So mostly we're going to focus on the converse angle pair theorems. These are the angle pairs that we already learned about. We're just saying that the converse is true. If two lines are cut by a transversal and the pair of angles is either congruent or supplementary, depending on which angle pair it is, then that will make the two lines parallel. So our congruent angle pairs are corresponding angles, alternate interior angles, and alternate exterior angles. So corresponding and the two that are named alternate. Remember that corresponding visibly is on the same side of the transversal. Alternate interior are between the parallel lines but on opposite sides of the transversal. And alternate exterior are outside of the pair of parallel lines and on opposite sides of the transversal. Our supplementary angle pairs are same side interior, which are between the parallel lines but on the same side of the transversal, and same side exterior, which are outside of the parallel lines but on the same side of the transversal. So corresponding is kind of your tricky one because they are on the same side of the transversal, but because they're also on the same side of each parallel line, it's the same position, they end up being congruent instead of supplementary. Our last converse theorem to focus on is the perpendicular transversal converse. In our class, we didn't really talk about the perpendicular transversal theorem that much, but the perpendicular transversal converse comes up in some of the questions, so I wanted to mention it. If two lines are perpendicular, which is this little symbol here, this upside down T, to the same line, then the two lines are parallel to each other. So if I have a figure like this, and these two are perpendicular, then I actually know that all 8 of the angles are right angles. So all my corresponding angles are congruent, all my alternate interior angles are congruent, all of the angles, all 4 of these angles are congruent, they're all 90 degrees. They're also all supplementary because 90 plus 90 equals 180. So every angle pair you can think of is both congruent and supplementary. So all of these statements end up true, which makes the two lines parallel. This theorem is very easy to prove, but it takes a couple of steps. So if you just know that they're perpendicular, you can save yourself a couple steps by using the perpendicular transversal converse instead of explaining that the angles are congruent because perpendicular lines form right angles and right angles are all congruent to each other. So to use these theorems, you use them in proofs. So if I'm given that angle 1 is congruent to angle 2, then these angles are corresponding angles. So I can use that corresponding angles converse to conclude that these two lines are parallel. It's important to make sure that you pick the correct lines though. Be careful. C and D have nothing to do with this angle pair because 1 and 2 are along C. So that makes C the transversal and A and B are the line pair. So we can say that line A is parallel to line B because of the corresponding angles converse. So when you're doing proofs, a lot of times you do some kind of backwards thinking where you start with your reason and then you go back to, okay, what was my conclusion? Because you have to look at what angle pair is it. Is that right? Corresponding angles are supposed to be congruent, so it does work. In a proof, it would look like this. I would say my statement would be angle 1 is congruent to angle 2. And my reason is given. And then I would say that line A is parallel to line B because of the corresponding angle converse postulate. And if I'm writing it by hand, a lot of times I'll use a bunch of abbreviations like cor for corresponding, the angle symbol instead of the word angle, conv for converse, post for postulate. You don't have to do abbreviations, but a lot of times I will do them when I'm handwriting things, and I know I'm going to run out of space. If I tried to write corresponding angles, converse, postulate out by hand, I'd be out to the edge of the paper. So for this one, angle 1 is congruent to angle 2. These are alternate interior angles. And their alternate interior angles are supposed to be congruent, so that makes these two lines parallel. Line C and line D. And I forgot the word converse. Now, for this one here, I'm given that angle 1 is congruent to angle 2. Angle 1 and angle 2 are same side interior angles. But same side interior angles are supposed to be supplementary, so we can't conclude anything useful from this. We were told that they're congruent, we want them to be supplementary, so that doesn't tell us anything useful. We could have these two angles be pointing inward towards each other, forming an isosceles triangle, or pointing away from each other, forming an isosceles triangle on the other side, or they could be right angles where they're congruent and supplementary, so they are forming parallel lines, but we don't know any of that. All we know is that they're congruent, which is nothing useful. So that one was a trick question, but watch out because those trick questions happen a lot. Now here we have the same figure, but we have the information that we actually want. This time we're told that they're supplementary, so I can't mark them congruent, so I'm just going to put a little dot next to them to remind me of which angles I'm focused on. But these guys are same side interior angles, but they are supplementary, which is what we want them to be. So that will tell us that C and D are parallel. So angle 1 and angle 2 are same side exterior angles, which are supposed to be supplementary. So we are able to conclude that line A is parallel to line B because they are acting as the pair of lines and line C is acting as the transversal. We're ignoring line D. Now for this last one, it's actually kind of a trick question. Angle 1 and angle 2 look kind of like corresponding angles, but they actually have nothing to do with each other. This intersection isn't connected to this intersection in any way. I could take line B and line D and move them around and it wouldn't affect angle 1. So because the two angles are completely unrelated, there's nothing that you can conclude. It's just a trick question. So there you have proving lines parallel in a coordinate plane.